Current in the case of resonance, in the case of series resonance, current since the impedance is parabolic shape, that is, as the frequency is increasing, impedance is decreasing, and therefore the current will increases. So that is why in case of series resonance, current versus frequency, if you look at the current versus frequency graph, the current is increasing like this. Current is increasing like this and attains a maximum value at this point. So where the impedance here is given by only pure resistance, which is equal to minimum. So when impedance is minimum, obviously the current is maximum. That is why at resonant frequency, yeah, the current in a series RLC circuit is maximum. So and it is given by V by R. So this is the graph. And after that, what will happen? Once again, the impedance increases. That we have seen. So when the impedance is increasing, the current will be trying to decrease it here. So before resonant frequency, the impedance is decreasing, and thereby current is increasing. And at resonance, the impedance will become minimum, and therefore the current will be maximum. And once again, when the current impedance is increasing after resonant frequency, the current will decay, right? And therefore the shape of the current graph is like this. And if the value of resistance is increases, then the maximum current at resonant frequency will also decreases. ఎందుకంటే resistance పెరుగుతున్న కొద్దీ current కూడా తగ్గుతుంది కాబట్టి. So this is a maximum current at resonant frequency when R is very small. Let this be R is equal to R1, and this is the resonance curve when resistance is R2 and where R2 is greater than R1, right? So now let us simply discuss about the voltage across the RLC elements. So we have observed that the current is initially is increasing and attains maximum at resonance and decreasing once again. Therefore, the voltage across the the voltage across the resistance is given by V is equal to R, right? And this would be maximum because I is maximum here. I is maximum here. So since I is maximum, the voltage across resistance is maximum at resonance and equal to the applied voltage. And this is equal to the applied voltage. That is VR is equal to V is equal to I into R in at resonance, right? Then the voltage across the inductance. So the expression for the voltage across inductance is I into XL. Both I and XL are increasing before resonance. That we have seen that both the graphs. Current is increasing before resonance and inductive reactance also increasing. And therefore the product must increasing. Therefore, at resonance, I is not changing, but XL is increasing. At resonance, I ఏమవుతుంది maximum value at అవుతుంది. కానీ XL is going to increase. Hence, the product should be increasing. The voltage across the inductor continues to increase until the reduction of current offsets the increasing XL. So, అంటే resonant frequency తర్వాత కూడా what will happen? The voltage will trying to increase since XL is increasing కాబట్టి. Therefore, at IXL is maximum after resonant frequency. Therefore, definitely the voltage VL would become maximum after resonant frequency F naught or F R, whatever it is, right? Therefore, in case of a voltage across the capacitor, VC is equal to I into XC. At resonance, I is constant and X is decreasing. So X decrease అవుతుంది కాబట్టి, therefore the product should be decreasing. And the product అప్పటికే resonant frequency decrease అవుతుంది కాబట్టి, hence IXC should have maximum before resonant frequency. Therefore, the variation of VR, VL, and VC are shown in figure like this. See here, this is the variation VR. This is the VR voltage across the resistor, and it is similar to this one. So here it attains a maximum value, which is given by applied voltage, right? IR, right? This is maximum voltage. And whereas when you come to the voltage across the inductor, voltage across the inductor also initially is increasing. See here, it is increasing like this, but attains a maximum value after resonant frequency. This is your resonant frequency. So it attains a maximum value at this point, the voltage across the inductor, because of the fact that the XL is still increasing after resonant frequency. And after this one, XL is I is decreasing, therefore I decrease అవుతుంది కాబట్టి, then therefore the voltage across the inductor will also decrease. Similarly, when you come to the voltage across the capacitor, VC, so initially before resonant frequency, current is increasing, and therefore your VC will also increases like this. VC will also increases along with this. And it attains a maximum value before resonant frequency. ఎందుకు దీని తర్వాత తగ్గిపోతుంది, ఎందుకంటే ఫ్రీక్వెన్సీ పెరుగుతున్న కొద్దీ XC is decreasing since after resonant frequency. Therefore, your voltage across the capacitor will attains a maximum at before resonant frequency. See here at this frequency. Now, if you look at that, at resonant frequency, both the voltages VC, both the voltages magnitudes VC, mod of VC and VL are same. So therefore, but they're of opposite sign. Therefore, that is why total voltage becomes net voltage between VC minus VL becomes 0 at this one. And therefore, that is why VR is equal to total applied voltage. This is the applied voltage, right? Because of this fact. Now, let us find out the frequency at which VL is maximum. So a simple derivation we have here, frequency at which VL becomes maximum. So that one, for that one, we just take the expression for VL. VL is equal to I into XL, and this I can write it as V by Z, where I can write it as V by Z, where Z is given by root over R square plus XL minus XC whole square. So now this XL, once again, I substitute XL is equal to omega L and XC is equal to 1 by omega C. Now, if you substitute all these quantities here, this here, you will get this expression. In place of XL, also you substitute omega L. Therefore, V into omega L by this you will get, right? Then this is equal to VL. Now take the square, VL square on both the sides, then simplify this equation. Then to determine the frequency at which VL is maximum, generally, is an expression, mathematical, we want to calculate the maximum or minimum. What we do, we take the derivative of the variable with respect to a variable. So in the here, the variable here it is, variable quantity here it is, frequency. So we have take the derivative of VL with respect to omega and equated to 0. Then when you take the derivative of this, you will get this. Right? It's a simple, straightforward derivation. Yeah, you need not worry about it. No? And ultimately, after simplification, so you will get this expression, right? This omega at which the VL becomes maximum in terms of radians per second. This is, and this is in terms of hertz. This expression, right? Then the second one is frequency at which VC is maximum. Same procedure we adopt here. So let us take what is the magnitude of voltage across the capacitor, I into XC. Once again, I we have represented as V by Z, where Z is once again is given by your expression which we have derived it earlier, right? And if you integrate and then if you simplify that equation and derive it with respect to the omega here, then you will get the condition for the frequency. You will get the condition for the frequency to obtain maximum voltage across the capacitor. So at this frequency in radians per second, the voltage across the capacitor will attain maximum, or at this frequency in terms of hertz, the voltage across the capacitor will attain its maximum. So these are two important expressions right now. Now let us we have a total summary of the resonance condition. Let us look at this. So at resonance condition, so the first important point is circuit is purely resistive, and power factor, since the circuit is purely resistive, the power factor of the circuit is unity. Then the current is maximum and is equal to V by R, and voltage across L is equal to voltage across C. That is VL, mod of VL is equal to mod of VC. Magnitudes are equal, but they are in opposite direction. Therefore, power factor of the circuit changes from leading to lagging with increasing frequency. ఎందుకంటే ఇనిషియల్ గా XC is more at lower frequency, that is before resonant frequency, XC in capacitor reactance is more కాబట్టి the power factor is leading, and after resonant frequency inductance is more కాబట్టి we say it is lagging.